Hello and welcome to my video. The flat earther Anthony Riley, aka Sleeping Warrior, is a very special person. Not only does he think that 5 divided by 0 is 5, not only does he not know what the sum of internal angles inside a triangle is, not only does he think that density is measured in parts per million, not only does he think that water falls down because invisible clouds in the sky somehow push it downwards, he has also debunked gravity by playing word games. And on top of that, he has invented the concept of relative density disequilibrium, which basically claims that gravity doesn't exist and that things fall down due to buoyancy. But relative density is so outdated already, which is why Sleeping Warrior now argues that it's not relative density that makes things fall down. It's relative density. Buckle up.
I want to ask for blurthers to explain to me a problem that I have, because I'm a dumb flat earther and I don't understand science. So I'm going to ask you guys a question that I expect some answers to, because I'm going to claim a debunk to this nonsense here, unless somebody can explain it using the explanation that is provided here. It says, an object falls down because of Earth's gravitational attraction. Well, we know gravitational attraction doesn't exist because it was replaced in 1915 by Einstein. It's the curvature of space-time caused by the uneven distribution of mass.
If you were actually interested in gravity instead of parroting flat earther propaganda, you would find that there's a lot of material about Einstein's general theory of relativity. Here we have an example where someone used this general theory of relativity to calculate how an apple would behave in the space-time metric of a massive spherical object. In other words, what happens if you put an apple next to a planet? And would you look at that? The apple accelerates downwards. Mass times acceleration is force, which means that yes, even in Einstein's general theory of relativity, gravity still is and remains a force. Now you ask, why didn't Einstein call it a force then? Because describing gravity mathematically as a force makes relativistic equations needlessly complicated. Force is the time derivative of momentum, so they are related. But when engaging issues with space-time, it is mathematically far more practical to describe your physical system in terms of energy and momentum than in terms of force, because that allows you to exploit certain mathematical symmetries that make the equations way nicer to write down and to solve. So, just to be clear, gravity acts as a force in the general theory of relativity, but Einstein willfully chose to not describe gravity via its property of being a force, for the sake of mathematical simplicity.
But anyway, I know they got to go back to old style history, historical science to explain their nonsense, but they think that the Earth attracts matter, right? Even though my egg went the opposite way. Anyway, I digress. But some denominations of flat Earth claim that an object falls down due to its density, not gravity. No, that's a false representation of the position, due to its relative density. Not density alone, relative density. So, by putting two objects of an equal density and a different mass against each other using a balance, it is easy to see that an object's density is not the reason it falls down. Okay, so here we see 2 litres of water against 1 litre of water. Same material, same atmosphere, same density, but different mass and different volume.
So, let's do a quick recap what we have here. On the right side we have 1 kilogram of water occupying a volume of 1 liter. The water is displacing 0.001225 kilogram of air, which would have occupied this volume of 1 liter instead. So the relative density on the right side is 816. Now, over on the left side we have 2 kilograms of water occupying a volume of 2 liters. The water is displacing 0.00245 kilogram of air, which would have occupied these 2 liters of volume instead. The relative density of the left side is also 816. The left side and the right side have perfectly identical relative density. Yet, for some reason, the bucket on the left side experiences a greater downward force.
Now, what this is trying to demonstrate is that although the two densities side by side on a balance bar basically outbalance each other, they're not balanced. The claim is that relative density or density is not the cause. And I can understand why, because it's obviously the amount of mass that's in there. But scales don't take into account volume, because if you were to basically, relative density is to the medium that you're in.
No. When calculating relative density, the volume cancels out, because the material you are looking at is occupying exactly the same amount of volume as it is displacing in the medium. And if Sleeping Warrior had ever calculated the relative density of anything, he would have known that.
It's not this is not a representation of relative density, because you've got one density here, you've got the same density there, but you're balancing them in a torsion over a balance thing that is not a representation of relative density.
Correct. This situation right here is not a representation of relative density. It merely shows how this relative density nonsense contradicts reality.
This is a representation of relative mass. This is not density, because density is mass over volume, and they're claiming that it's a different level of mass, but the same. Well, I don't quite see how this is the same, because the amount of mass per volume here and the amount of mass per volume there is the same in density's sake, but you're not doing them relative to each other. They've got to be relative to each other, not contrasted with each other.
Okay, so in order to understand why the left bucket experiences more downward force, we are supposed to look at the relative densities relative to each other? Let's do that. So the left bucket has a relative density of 816, and the right bucket has a relative density of 816, which means that both buckets have a relative density of 1. And how does a relative density of 1 tell us which bucket will go down and which bucket will go up?
So this is essentially a misrepresentation, because it isn't demonstrating relative density. It's demonstrating relative mass, because scales don't take into consideration the volume in any way.
Neither does your relative density hogwash or your relative density hogwash, because the volume cancels out in the equation.
For this to be an accurate representation, of course, you would have to get 2 litres of one object, 1 litre of another object of the same thing, put them in a container of some kind of sealed container, and then submerge them in some kind of medium to see whether or not there is a difference between the two.
Both buckets are already submerged in the medium air. Oh, and here comes the fun part of the video. Listen to Sleeping Warrior blathering on how it's mass that pulls one side of the scale down, except it isn't mass, and how he demands that we account for volume, except his own relative density humbug doesn't account for volume either.
So here's the key bit for the blurthers. If you think that this debunks the claim that relative density explains away gravity, then I'd like you to tell me what would happen in the following situation. On one side of the balance scale, we have 5 eggs, and I use eggs again because I'm going to show you why in a minute. So on this side, we've got 5 eggs. They can be farm eggs, they can be battery eggs, doesn't matter what eggs they are, just eggs. And on the other side, we're just going to put 1 egg. Now, on this balance bar, 1 egg on one side is going to go up in the air. 5 eggs down here is going to go down towards the ground, because the mass of the 5 eggs is greater than the mass of here. But no account for volume is taken into consideration, and there is no relative state here, because they're using the mass. There's no volume involved.
But, Sleepy, why would the bucket with the 5 eggs go down? You still haven't explained that. It's exactly the same situation as with the water above. Nothing has changed. Both sides have identical relative density, and their relative density is 1. So why would you assume that the bucket with 5 eggs has a bigger downwards force than the bucket with 1 egg? And why are you suddenly talking about eggs?
This is all done in the medium of air. Blurthers, what would be the position if I changed the medium of air with the 5 eggs on one side and the 1 egg on the other, and I made it a saline solution?
And here we are. He cannot explain how his relative density Horsescheit and relative density Horsescheit works in air, so he simply runs away like the sorry coward he is and changes topics and talks about eggs in salt water instead. Again, because he's a one-trick pony.
And it was I'll cherry pick it so that it matches the average density of 1 egg and the average density of 5 eggs. I'm going to assert that it balances these scales because we know that 5 eggs relative balance, the relative density of 5 eggs is equal to the relative density of 1 egg because they're the same.
But the same is true for air. In air, both sides have identical relative density and the scale goes off balance. In brine, both sides also have identical relative density, and yet for some magic reason the scale suddenly goes in balance. Why, Sleepy? That is the question you are running away from, you intellectually dishonest, filthy little coward. Both sides of the scale always have identical relative density in any medium. That relative density that you demand, that we take into account, is always the same for any medium. So why is the scale in balance for one medium and off balance for another medium, even though in both cases the relative densities are identical and the relative densities are also identical?
So, if you guys think that mass is the reason why these scales are distorted, like we're unbalanced, how would you answer the question if there were 5 eggs on one side and 1 egg on the other side, and they then balanced in brine water? How would you address that in mass? Because according to your explanation here, mass is the reason why these are wonky. So therefore, if I change the density of the medium, it should stay the same because mass is double on one side or 5 times bigger on one side, and it shouldn't balance out. But Flirthers absolutely realise what's going to happen because your 5 eggs are going to become the same as the 1 egg because relatively dense to each other, they are the same to the medium, relative to the medium.
Yes, they are the same relative to the medium. They are the same relative to the medium air, and they are the same relative to the medium brine, and yet, despite them being the same every single time, the scale is somehow off balance in some cases and in balance in other cases.
So these scales are going to balance, aren't they? So what's the explanation if mass is supposed to be the cause?
Okie dokie. You asked for it. The mass of an egg is 49.6 grams. The volume of an egg is 43 milliliters. Thus, the density of an egg is 1.15 kilograms per liter. 5 eggs have a mass of 248 grams and a volume of 215 milliliters. Thus, the density of 5 eggs is also 1.15 kilograms per liter. The density of air is 0.001225 kilograms per liter, and the density of brine is, according to your demands, 1.15 kilograms per liter. Now, the formula for buoyancy is very simple. To calculate the force by which an object moves up or down, you simply need the gravitational weight of the object itself minus the gravitational weight of the volume of the medium that the object has displaced. Now, let's look at the cases. In air, the 1 egg and the 5 eggs experience a downwards force, that is gravity, and an upwards force that stems from the air density. 5 eggs have 5 times the downwards force of 1 egg. The bucket with 5 eggs goes down. In brine, the 1 egg and the 5 eggs also experience a downwards force due to gravity, but this time the upwards force from the medium's density is so big that it exactly cancels out the downwards force. the sum of both forces is 0, and in total neither the 5 eggs nor the 1 egg experience a force. That wasn't so hard, was it? And here is my challenge for Sleeping Warrior. Do exactly these calculations for your relative density theory. How many newtons of downward force do 5 eggs experience in air? How many newtons of downward force does 1 egg experience in air? How many newtons of downward force do 5 eggs experience in brine? How many newtons of downward force does 1 egg experience in brine? Full disclosure. Sleeping Warrior, I think you are an intellectually dishonest bullshit artist, and the purpose of this challenge is to expose your incompetence as a researcher, to expose your continued refusal to explain your theory, and to expose your continued refusal to test your own theory scientifically. With that having been said, thank you everyone for watching my video, and goodbye.